Hey everyone, welcome back. We all want to keep up with what's happening, right?
Yeah.
I mean, without having to wade through tons of information.
Absolutely. Efficiency is key.
That's what we're all about here, getting right to the heart of things. And today, well, we've got a pretty big development to unpack. On March 12th, 2025, Google DeepMind made a significant announcement. It's all about bringing AI, artificial intelligence, into the real world, like the physical world we all live in. And they're calling it Gemini Robotics.
Yeah, this is a really interesting step. For a while now, even with all the advancements in AI, most of it's been happening inside
Yeah,
computers.
kind of behind the scenes.
Right, exactly. So what we want to do today in this deep dive is really break down what these new Gemini robotics models are all about. What can they actually do when they're interacting with the physical world around us, like objects and spaces and people? That's the big question here.
For sure. And there are actually two models to keep in mind here. Gemini Robotics, and then there's also Gemini Robotics-ER. Both of these are built on what they call Gemini 2.0. So to start off, maybe you could give us a high-level overview. What's the main challenge they're trying to solve with this new development?
Okay, so the fundamental hurdle here, the thing that they're really trying to crack, is this concept of embodied reasoning.
Okay, embodied reasoning. Break that down for us.
So think of it like this. A computer, right? It can process information, it can analyze data, all that. But to really interact with the physical world, like to understand how things are arranged in space, to react when something changes, and then to actually perform actions based on all that, well, that requires a whole different level of understanding. It's not just about processing information, it's about understanding your place in the physical world and acting accordingly.
Okay. What are the core abilities that Google DeepMind is aiming for with Gemini Robotics? What would make it truly helpful in real-world situations?
Right, so they're really focused on three main qualities. First, they want it to be general, adaptable. That means it can handle all kinds of different situations, even new ones it's never encountered before.
Most importantly, Gemini Robotics is general. It uses Gemini 2.0's world understanding to generalize across a vast range of real-world tasks.
New objects, different instructions, unfamiliar environments, all that.
So it's not just programmed for one specific task or environment.
Right. It's more flexible than that. And they've actually run some benchmarks comparing it to other leading VLA models. And the results are pretty amazing. Apparently, Gemini Robotics more than doubled the performance of the other models when it comes to this kind of generalization.
Right, more than double. So it's significantly better at handling new situations.
Yes, that's what it seems like. It's a pretty big leap in terms of its ability to deal with the unexpected, to adapt and figure things out in new contexts.
Wow, that really highlights its adaptability. All right, so that's generality. What's the second critical ability they're targeting?
Okay, so the second one is interactivity. In the real world, robots aren't going to be working in isolation. They need to work alongside people, be responsive to their surroundings, all in real time.
Yeah.
Gemini Robotics is interactive.
Can you put the bananas in the clear container?
Notice how we move the objects and the model reacts and replans on the fly.
Can you put the grapes in the clear container?
Our model's low latency means it can respond live to rapidly changing conditions and instructions. This same model can generalize to all kinds of applications where you can collaborate with the robot live.
Yeah, that makes sense.
So Gemini Robotics is designed to understand and respond to everyday spoken language, and not just in English, but in multiple languages. And it can adapt to changes, like if something in the environment moves, or if the instructions for a task are modified. Imagine a robot is trying to pick up an object and that object slips or someone moves it. Gemini Robotics is designed to be able to react to that, adjust its plan, and still complete the task.
Ah, that's important. A robot that can't react to a changing situation wouldn't be very helpful.
Exactly. It needs to be able to think on its feet, so to speak. All right, so we've got generality for new situations, interactivity to respond in real time. What's the third essential quality?
Okay, so we've got adaptability, we've got responsiveness. What's the third one?
The third one is dexterity.
Gemini Robotics is dexterous. High dexterity tasks are some of the biggest challenges in robotics.
I can fold the orange square into an origami fox.
That sounds fun. Why don't we try that?
Sure. Did you know that the word origami comes from the Japanese words ori, meaning to fold, and kami, meaning paper?
These capabilities are enabled by Gemini 2.0's spatial understanding of detailed aspects of things in your world.
You know, we humans take for granted how incredibly skilled we are with our hands.
Yeah, I've never thought about it, but it's true.
We can do all sorts of intricate, precise movements without even thinking about it, and that's something that robots have traditionally struggled with.
Right. I've seen those videos of robots trying to do things like open doors or pick up delicate objects. It doesn't always go smoothly.
Yeah, exactly. So Google DeepMind designed Gemini Robotics to enable robots to perform these complex tasks that require really precise manipulation. They gave examples like folding origami or carefully packing a snack.
Origami folding. That's a pretty good example of fine motor control.
Right. It's about much more than just picking things up and putting them down. It's about having that level of control and precision that we see in humans.
That's pretty remarkable. Now, I'm curious, is Gemini Robotics designed for just one specific type of robot, or can it be used more broadly?
That's a great question. It's actually designed for multiple embodiments. What that means is that it's not limited to just one type of robot. They mainly trained it using their own robot called Aloha 2. It's a bi-arm robot, so it has 2 arms. But they've also shown that it can control other types of robots.
Like what?
Well, for example, they've used it with a system that uses Franca arms. Those are pretty common in robotics research. And they're even looking at the possibility of adapting Gemini Robotics to even more complex robots, like the Apptronik Apollo. Have you heard of that one?
I don't think so.
It's a humanoid robot, kind of looks like a person.
Oh, wow.